Well, hello there. We're going to continue our unit on solving polynomial equations, which means we're going to continue factoring expressions. And so we're going to factor what are called specials. And in order for this to work out, you have to remember a few things from older material. When we were multiplying polynomials, we actually learned a couple of shortcuts as far as, what are specials. So when we were talking about multiplying back in the day, we were multiplying specials. So for example, we had a plus b squared, we had a minus b squared, we had a plus b, and a minus b. Those were specials that we had multiplied out, and they had worked themselves out into neat little things. And so when we had multiplied out a plus b squared, we ended up getting a squared plus 2ab plus b squared. When we multiplied a minus b squared, we ended up with a squared minus 2ab plus b squared. And then when we multiplied our two conjugates, hopefully you remember that vocab word, conjugates. When we multiplied our conjugates, we ended up with a difference of squares, a squared minus b squared. So we have to remember our specials. Now what we're doing is factoring. So factoring just means we're going the other way, right? So when we were multiplying out, we'd go this way. When we're factoring, we go the other way. So with factoring, this is all about recognition. It's all about recognition. Can you recognize what's happening in expressions, and can you recognize specials? So if you can recognize specials, you're going to realize that factoring can become a whole lot easier. So this is all about recognizing what's happening. So if we factor all of these special polynomials, we end up, in this case, if it's a squared plus 2ab plus b squared, we end up with a plus b squared. In this case, if it's a squared minus 2ab plus b squared, then a minus b squared, and then a squared minus b squared into conjugates, a minus b, a plus b. And everything is about recognition. So if you can recognize it, you can use the shortcut. So that's the note. If you can recognize it, use the shortcut. So if you can't, then factor it the long way. All right, so if you can recognize it, use the shortcut. If not, please remember how a trinomial in standard form looks and factor it that way. Okay, so if not, make sure you remember how a trinomial looks and then factor it that way. And the reason why that's important is because if you have a squared minus b squared, please take a note that there is no middle term. Okay, so you'll see that in a second. So this is all about recognition, right? All about recognition. So we look at factoring specials, and can you recognize some things that are going on? So we look at our first expression, x squared minus 10x plus 25. You can totally factor this any way you'd like. Okay, you can. You can use the x factor method. You can factor by grouping, but hopefully you can recognize that this is a perfect square trinomial. This happens to be a perfect square trinomial. It's a squared minus 2ab plus b squared. It just so happens that a is x and b is 5, right? So it totally happens that in this case, a is x and b is 25, right? So if we're using, in this case, then we can recognize this as a special. We can easily factor super quick, right? So it's just recognition. Can you recognize what's happening? And again, if not, totally use the long way. All right, so the long way, again, you can always use it. Doesn't matter which way. I'll use factor by grouping. And you can find out, okay, a times c is 25. What two numbers multiply 25 but add the negative 10? You'd end up with negative 5 and negative 5. You can always do it this way. There's nothing stopping you from taking a couple more minutes to factor this correctly. All right, so you just got to be careful with signs as normal. and you end up with the same thing, right? So you end up with x minus 5 times x minus 5, which of course is x minus 5 squared. But the deal with factoring specials is recognizing that they are. Okay, so that's the key there. When we look at number 2, hopefully again you have recognized number 2 happens to be a special, right? So if you can recognize what's going on, you would see that this is actually a squared plus 2ab plus b squared, or 4x is a, right? B is going to be 1, right? And so we end up with 4x plus 1 squared. That's going to be our result when we factor that trinomial. But this is all about recognition to use shortcuts. Again, you can use factor by grouping. You can use the x factor method. Whichever way, you're going to get to the same result. All right. Now, in this this next one, becomes a little bit interesting. So we look at number 3. And this is where we hit pause. All right. So number 3, we have an interesting looking expression, right? And hopefully you see what is about to occur. Now, in this expression, we look at it and we're thinking, brr, that's not a special. And you would be right in making that assumption that that is not a special. But what can we do? Hopefully you see that there is a greatest common factor. Remember, that's still the same. Greatest common factor first. And do you see that there is a greatest common factor? Do you see that it is x to the second power? And so when we have x to the second power as our greatest common factor, and we factor out x squared, we're left with a trinomial that fits a certain pattern. Okay, so we can be left with this. Now, I know that this is a special trinomial. Do you know that this is a special trinomial? And do you have to know? No, you don't have to. Again, because you can always look at this the long way. Okay, so remember we have 9y squared blank y plus 4, right? The two multiply 8 times c, 9 times 4, 36. What two numbers multiply to 36? Add to 12, 6 and 6, right? So you can always do this the long way. So you finish factoring that. You can do it that way. When you're finishing factoring that, you will discover what I recognize here. Okay, and if you don't recognize it, that's fine, because you're going to discover this. It's 3y plus 2 squared. Okay, and you'll find out factoring this way. If you factor this by grouping, you get to the same result. But this is our result. But remember the trick, always the greatest common factor first. Okay, so if you can find the greatest common factor, do so, and then you're left with a neat quadratic trinomial for number 3. And that's how that one works. So this is, again, all about recognizing your specials. Do you recognize specials, and can you work with them? So let's move on to the next one, number 4. Okay, I'm going to show you number 4, the quick way and the long way. Hopefully you recognize number 4 as a special. And if you recognize number 4 as a special, you're done. Okay, so number 4, no doubt, is a special. But can you recognize it? You'd be done. Now, what if you didn't recognize this as a special? How could you factor this the long way? Here's how. You're going to separate the middle term into blanks. But what is the middle term? It's not negative 100. Negative 100 is already there. Okay, so if we were to factor this the long way, this is what we would do. If we're going to do factor by grouping or even the x factor method, you would end up with blank x in the middle. The question then would be, what multiplies to negative 100 but adds to 0, right? What multiplies to negative 100 adds to 0. And so that's going to be the trick if you don't see the fact that this is a special. Okay, so what multiplies to negative 100 but adds to 0 is going to be the question. And hopefully by now you see negative 10 and positive 10. And then you would see what hopefully you should be able to see immediately. that this special is a difference of squares. And remember the note, a difference of squares is related to conjugates. Okay? A difference of squares factors into conjugates. So that's a huge note. A difference of squares factors into conjugates. And if you can recognize a difference of squares, man, are you set. Because this is super quick, but you have to be able to recognize what's going on. All right, so we have our factors when we factor that expression. And you can get to there as long as you recognize that the middle term is 0. Okay, so you can still do this the long way, but know that the middle term is 0. Okay, so you can totally do this. And that's how number 4 would work. All right, number 5 is where stuff gets nuts. There is a long way to do this and a short way to do this. So let's do the long way first. Okay, there's a long way to do this and a short way to do this. So the long way first. Now the long way is going to be tricky. The long way. Multiply everything out. Step 1. Step 2 then, simplify the expression. And then step 3, factor what you have left. Okay, so you can do it this way. I'm going to do it this way first. So the long way first. We're going to multiply everything out. We're going to simplify the expression. We're going to factor what's left. That's the long way. All right, so when we multiply everything out, we're going to first multiply x plus 4 squared. So you can use the area model. You can use whatever it is you're going to do. But we'll multiply x plus 4 squared. So we have x plus 4 plus 8x plus 16. That's x plus 4 squared. Then we have our minus 49. All right, so we've multiplied everything out. Now we're going to simplify the expression so we can combine our like terms. We'd have x squared plus 8x, and then we have to add 16 to negative 49, which would give us negative 33. So we have x squared plus 8x minus 33. And then we can factor what's left. Okay, so we factor what's left. We can use grouping, or we could use the mental math shortcut. The two numbers that multiply to negative 33 but add to positive 8 are negative 3 and positive 11. And then we factor by grouping. X times x minus 3, and then plus 11 times x minus 3, or x minus 3, x plus 11. So that's the long way. We're going to get to this result. Okay, so the long way is to multiply everything out, simplify what you have, and factor what's left. The short way is to recognize. So if you can recognize what is happening, you should be able to recognize a difference of squares. Do you recognize a difference of squares? We have a thing to the second power minus another thing to the second power. We have a perfect square minus another perfect square. So we have a difference of squares, which means it can factor into conjugates, which would be x plus 4 minus 7, and then x plus 4 plus 7. If you can recognize conjugates, we are super set to go, and then we can just simplify what's left. So if we simplify what we have left, we can combine like terms. We can read this out loud. X plus 4 minus 7. We can do the plus 4 minus 7. We can do that. That would be x minus 3. And then we read this out loud. X plus 4 plus 7. We can do the plus 4 plus 7. It's x plus 11. And we're good that way. All right, so if you can recognize stuff, your life becomes easier. And that's just the point of this lesson. And there are some things that you can't avoid. Anyway, so we have that situation. Okay, so the long way can multiply everything out, simplify the expression, factor what's left. Totally, totally doable. But now on to number 6. Now, number 6 you can use the substitution method that we had talked about in the previous lesson. So if we're working out number 6, you can always use the substitution method because we could substitute x to the second power, or a to the second power for x to the fourth, and then factor it that way. Or we can just recognize a difference of squares. Okay, and if you can recognize a difference of squares, your life becomes easier. And if you recognize a difference of squares, you're going to end up with 4x squared minus 9 times 4x squared plus 9. All right, so we can recognize that and then think we're done. But wait, we are not done. You must always pay attention. We are not done. Can you believe that? Why not? Why aren't we done? Can you recognize a difference of squares again? Can you recognize a difference of squares again? And hopefully you can recognize 4x squared minus 9 is a difference of squares. Okay, so you always have to play heads up ball. Recognize 4x squared minus 9 as a difference of squares. And if you can factor, you must factor. Okay, so if we can factor that, we must factor that. And so 4x squared minus 9 happens to be 2x minus 3 times 2x plus 3. So we have to be able to recognize what's going on and continue factoring. Okay, so always keep your head above water. Always pay attention to what's going on around you, and you'll be able to see what's happening here. So we're not done. What we have to do then is factor what we can. So 2x minus 3, 2x plus 3. And this is a sum of squares. We have no way to factor that. We're going to get imaginary results. So we would end up with our finally factored product. Right? So we have to always play heads up ball. The entire point of the lesson is to play heads up ball. All right? So it's almost like a bonus lesson. If you're able to play heads up ball, this one's for you. Okay? So this is a neat one. Now, do we have to do it this way? No. Again, what you could have done is use substitution. And either way, once you hit to the substitution piece, you should still recognize that we have quadratic polynomials, and we might be able to factor them. And in this case, we can. So always factor what you can. Okay? So always factor what you can is a huge note. Because then you'll be able to graph stuff. Then you want to be able to graph accurately. Always factor what you can. Huge note. All right? Now, we saved the best for last. This is all about heads up ball. If you can recognize what you see here, then you are golden, right where I need you to be. If you can't recognize what you see here, make sure you're doing your homework. In fact, if you haven't worked on any assignments for this and you can't recognize what you see here, you ought to hit pause, do your homework, and then bring it back. Okay, the only way you can do, there is no long way to factor this appropriately. This is all about recognition. So, have you recognized anything yet? I hope you have. You better recognize your perfect square trinomials. So it's all about recognition. Recognize your perfect square trinomials. And what does this have to do with anything? This is a good one. All right, so we recognize our perfect square trinomial. Now, what are we going to do with that perfect square trinomial? Of course, we're going to factor it. Of course, we know that this is going to be x plus 10 squared. And then we have our minus x to the fourth. All right, so we have that. So we've gotten this far. Do you recognize again? I love this one. So let's recognize again. What do you recognize? What do you see? Do you see a difference of squares? I hope you do. a perfect square minus a perfect square. I hope you see that. And that will multiply or factor into conjugates. So we have 1 perfect square, x plus 10 minus x squared, and then the same term plus x squared. So we have our 2 factors, and this is a fun one. This is a really fun one. Now, what we can do from here to make it look pretty is simplify each one. So we could have negative x squared plus x minus 10, that trinomial, and then x squared plus x plus 10, that trinomial. And we know that neither of those we can no longer factor either of these, because there are no numbers that multiply to 10 but add to 1, and no numbers that multiply to 10 but add to 1. So we're done. This is the completely factored form of the original expression. And the only way you can do it is to recognize what's happening. So once again, if you didn't see this as your perfect square trinomial, make sure you're doing your homework, right? So you can get the practice. The only way to learn math is to do math. Okay, so this is a fun one. I love this lesson because you have to be able to play heads-up ball and recognize everything that's happening around you. Always recognize your specials. All right, so that's it for the lesson. Good luck with the assignments, and I'll see you in the next lesson.